Dear students, today we are going to see Boolean postulates and laws. Actually, we know that in digital systems we are dealing with zeros and ones. So, the arithmetic of zeros and one are entirely different compared to the decimal number system. So, an English mathematician in the 19th century itself has developed an algebra with zeros and ones. We can say it's a Boolean algebra. So, we are utilizing these theorems of George Boole to design modern digital computer systems. So, he has developed so many postulates as well as theorems, and other theorems are also available. So, we will see the basic postulates of Boolean algebra. It is quite simple only. We will just have a glance of these postulates. As we have seen in AND operation, the postulates with AND gates or the AND operations are like this: 0 into 0 is 0, 0 into 1. Actually, this is the AND operation. It is denoted by the dot, 0 dot 1 or 0 into 1. Simply we can say it's 0, 1 into 0, 0. In mathematics also it follows in the similar manner. So, 1 into 1 is 1. Similarly, we have OR operations, axioms 5, 6, 7 and 8. Then not operation, axiom 9 and 10, 1 bar is equal to 0 and 0 bar is equal to 1. Then he has the laws, few laws are there. So, first one is complementation law, 0 bar is equal to 1 and 1 bar is equal to 0. Third law is if A is equal to 0, then A bar is equal to 1. Fourth law is if A is equal to 1, then A bar is equal to 0. Similarly, A double complement, A bar is equal to A. Then AND laws are there. Okay, you can see null law, identity law. Then A into A is equal to A into A bar is equal to 0. For any value of A, all these are holding good. Then OR laws are there. Again, we have the null law, identity law. Then A plus A is equal to, the third law it's called A plus A is equal to A. Fourth law, A plus A bar is equal to A itself. Again, commutative law, just like ordinary mathematics, A plus B is equal to B plus A into B is equal to BA. All these are followed by the digital numbers or the binary number system also. Then associative law, A plus B plus C is equal to A plus B plus C. For the AND operation also, this is same, A into B C is equal to A into B into C. Then distributive law, this is a here you can see a difference. The first law is quite common, A into B plus C is equal to AB plus AC. Then second law, that is particular for the Boolean algebra, A plus BC is equal to A plus B into A plus C. So, this is called the second distributive law. It is applied in many cases of the reduction of equations. So, A plus BC is equal to A plus B into A plus C. This is the second distributive law. Then we have a redundant literal rule, that is RLR. A plus A bar B is equal to A plus B. That is, when we are applying the second distributive law, you can get this. So, it can be proved simply by applying the second distributive law, that is called the redundant literal rule. Then A into A bar plus B is equal to AB. Then idempotent laws, A dot A is equal to A and A plus A is equal to again A. There is no A square or there is no 2A, because all the A or B, they can take only two values, 0 and 1. Then absorption law, a plus ab is equal to a, and a into a plus b is equal to a. Then there is another theorem, it is called the consensus theorem or included factor theorem. Here you can see that ab plus a bar c plus bc is equal to ab plus a bar c. The bc vanishes here. It can be proved easily. So, this is called the consensus theorem. Similarly, the second theorem, here also one more term is vanishing. A plus b into a bar plus c into b plus c is equal to a plus b into a bar plus c. Then transportation theorem, an expansion of this, that is ab plus a bar c is equal to a plus c into a bar plus b. Then there is an important theorem. Okay, it is not by George Boole, it is by another scientist. It is called the De Morgan's theorem. Very important for a digital system is concerned. That is a plus b the whole complement is equal to a bar into b bar. Similarly, ab the whole complement is equal to a bar plus b bar. This is very important. It is known as De Morgan's theorem. Then there is a principle of duality. That is, the duality principle states that every algebraic expression deducible from the postulates of Boolean algebra remains valid if the operations as well as the identity elements are interchanged. Okay, so two elements are there for any binary, that is 0 and 1. The operations are the basic operations and or. So, any equations, okay, or any operations by and can be replaced by or. Similarly, 1 can be replaced by 0 also, provided there is a change in operation. For example, the dual of 0, it is 0 bar is equal to 1. Okay. So, then 1 bar is equal to 0. Similarly, 0 into 1 is equal to 0, its dual is 1 plus 0 is equal to 1. You can see 0 into 1 or 1 into 0, the AND operation, it is giving a value 0. Its OR operation is 1 plus 0 and it gives a value which is the dual of 0, nothing but 1. Similarly, a dot 0 is equal to 0, a plus 1 is equal to 1. Then ab is equal to ba. Similarly, here a plus b is equal to b plus a. Okay. So, for any expression is concerned, if you are changing 1 into 0 and AND operation into OR operation, you can get its dual. So, only two states are there and its dual is OR and 1 its dual is 0. Thank you, that is all.